All right, welcome back to college algebra final exam prep. So our last two problems here. All right, number 11 is exponential model. It's a kind of thing that I would hand you the formula and ask you some questions about it. Okay. So a pizza is taken from an oven at 425 degrees Fahrenheit, placed on a counter to cool. The temperature in the kitchen is 75 degrees Fahrenheit. Use the model. Temperature is equal to 75 plus 350 e to the kt. Excuse me. Where temperature is T is the temperature in Fahrenheit, T is the time in minutes. There we go. If a pizza cools to 90 degrees Fahrenheit after 9 minutes, how long will it cool to take to 110? I know it's a kind of a weird way of asking that. Okay, and there's other questions we could ask, but here we go. We are given that T is equal to, what is that? 75 plus 350. 350 e to the kt. We know that in 9 minutes, right? So in 9 minutes, we'll say a similar pizza could cool to 90 degrees. Okay, just assume that these people eating the pizzas perform this experiment more than one time, okay? And then how long to cool to, what is it, 110? All right, so in 9 minutes, it cools to 90 degrees. So let's go ahead and use that on here. Okay, so we're going to say here's 90 is equal to 75 plus 350 e to the 9k. In this case, I think k is going to be negative. Okay, so we're just going to allow that to happen. And we have to solve for k. Not so bad. So let's go ahead and subtract 75 from both sides here. Okay. So I think that's going to be 15 is equal to 350 e to the 9k. Let's go ahead and divide by 350, divide by 350. Okay, so we have e to the 9k, and this is equal to, no idea what 15 over 350 is going to look like. Okay, 15 divided by 350, and let's go ahead and make it easier to write. Turn it into a fraction. 3 over 70. Great. Okay, so this is 3/70ths. All right, so we have to solve for k. It's in the exponent position. What do we do with variables in the exponent positions? We use logarithms to get them down. So let's go ahead and take the natural log of both sides. So that's natural log of 3/70ths is equal to natural log e to the 9k. This bit here, this comes down in front. We have 9k, natural log of e. You know the natural log of e, though. You know that the natural log of e is 1, so we can cross that out, put in a 1. And what we're going to have here, we still have is equal to ln 3/70ths. Okay, solving for k, so we're going to divide both sides by 9, or multiply by 1/9, that means the same thing. Okay, so we have 1 over 9 ln 3/70 is equal to k. When you take the natural log of a fraction less than 1, okay, we get a negative number. So I know this is going to be negative. Okay, but there's my k. KP for pizza. Okay. All right, let's go ahead and get the rest of this. How long is it going to take to cool to 110? Okay. So again, we're going to say we have T is equal to, what is this? 75 plus 350 e to the kp times t. Now we're solving for t, okay, little t. So we know that this is going to be 110, okay, equals 75 plus 350 e to the kp times t. got to solve for t. So subtract the 75, subtract the 75. What's that? 110 minus 80 is 30, but we have to add 5 more. So I think we're going to get 35 here. Yeah, that is equal to, oh, wow. I really should have picked this problem for your final. This is nice, right? 35 over 350 equals e to the kp times t. Look at that. Right, that's 35 divided by, right, this is 35 over 35 times 10. That cancels. So we just get 1 over 10 equals e to the kp times t. Solving for t, which means the variable is in the exponent position. How do we get it down? We take a natural log. All right, so that's 1 over 10 is equal to the natural log of e to the kp. Remember, we know what this is, right? We calculated this in the previous spot. So this is a number, right? This bit comes down in front. So we have kp, something we know, times t, ln of e. But you know the ln of e is, right? You know that's 1. You know it is. And then over here we have natural log of 1/10. So t is equal to ln of 1 over 10 divided by whatever kp was. Right? That's my cooling constant for pizza. So t is equal to the natural log of 1 over 10 divided by, what is kp? Kp was 1 over 9 ln, and this was what, 3/70ths? Okay, so here I'm going to do a little bit. I'm going to say, well, this is 9 over 1 over 9 over 1. 9 over 9, right? That's 1, right? So this will cancel this out. So we have t is equal to 9 ln 1 over 10 divided by ln 3/70. Excuse me. Okay. Calculator time. Oh, there's going to be more of that. This is 9 times natural log 0.1, that's 1/10, right? Divided by, divided by, not like that. Okay. ln, and then we have 3/70ths. It's important to end this parentheses, otherwise it'll take the natural log of all of this stuff. You'll have like natural log of natural log stuff, and you don't want that. Okay, so we're just going to end the parentheses, close the parentheses, and be done with it. And get that t is, for the people absolutely jonesing for that pizza, and I'm using a stopwatch here, 6.58 seconds, right? Or no, 6.58 minutes. And then we could take our 0.58 minutes times 60 seconds to 1 minute. Cancel that. So 0.58. Right, we won't do 6, right? Because that's 6 minutes times 60, right? For my 60 seconds. So we have 6 minutes, and what do we have on our calculator? 34.8 seconds. If you really want that pizza as soon as possible. Okay, so that's how you solve a problem like that. There could be other questions here, all right? Like, what if I asked you, what's the temperature of the pizza the moment it gets out of the oven? Well, T is 0, right? So we have, at time equals 0, we're going to have 75 plus 350 e to the k. I don't even care what that is, times 0. E to the 0, that's 1. So it's 75 plus 350. Wouldn't you know, it's 425. Okay, so I could ask you a couple of questions that you kind of already know the answer to, but that's really, like what temperature will it be? What temp after, it's in minutes, right? What temperature will it be after 120 minutes? Can't imagine somebody leaving pizza on the counter for 2 hours, but maybe the movie was really good, right? So we could type all of this in, right? T is equal to 120 and get the value there. Okay, the longer it goes, the closer your answer is going to be to what? To 75 degrees, because that's room temperature, right? So if you ever get something lower than 75 degrees, you know you screwed up, because never once have I left a pizza on the counter and had it turn out to be colder than the room it was in. Okay, so I could ask you a couple of questions like that just to test out your calculator abilities. But I think that's the hardest part of this particular problem on the final, so we'll go with that. Okay, so very good. I will see you for the next and final question. Right. So.